The shocking 250% brightness increase of Betelgeuse. Betelgeuse, the star positioned on the shoulder of Orion's mighty warrior, has been displaying unusual patterns of activity, sparking excitement over a rare, potentially once-in-a-lifetime cosmic event. Some experts propose that this increase in brightness might indicate the star's approach toward a supernova. However, the precise timing of this event remains unclear. An expert suggests it could happen in the not-too-distant future. Let's delve into the present state of this star. 35 seconds. If you wish to stay updated on the latest news from the universe, including all its mysteries, consider subscribing to our channel, liking this video, and activating the notification bell. Even if you haven't personally encountered it by name, you've likely seen the dazzling Betelgeuse, a brilliant red star that gleams in the constellation of Orion. Betelgeuse is a truly spectacular sight. Currently, it is an extremely massive star. If we were to place it at the center of our solar system, its surface would extend beyond the orbit of Mars. This enormous and easily visible star continues to captivate observers because it is relatively close to our galaxy. Betelgeuse undergoes noticeable changes, fluctuating in brightness. This is typical of semi-regular variable stars, where brightness may shift dramatically as they approach their final collapse into a supernova explosion. Recently, Betelgeuse has been even more intriguing due to sudden and unexpected changes in its luminosity, a phenomenon that remains perplexing. 1 minute and 40 seconds. Though its strange behavior was already unusual, it became even more captivating due to the great dimming event that took place between 2019 and 2020. During this event, the closest red supergiant star to Earth shone twice as brightly, lighting up the early evening sky in the southern hemisphere. This abnormal behavior from one of the brightest stars in the sky has granted scientists an extraordinary chance to observe Betelgeuse's rapid transition from brightness to dimness. In more recent times, Betelgeuse has exhibited increases in its brightness of over 50%. On May 20, 2023, a Twitter account named Betelgeuse, dedicated to tracking the star, reported a remarkable 142% surge in brightness, citing information from the American Variable Star Observing Association. Andrew Dupree, an astrophysicist from the Harvard-Smithsonian Center for Astrophysics, notes that Betelgeuse is now ranked as the 7th brightest star in the night sky, moving up 3 positions from its usual spot at 10th. In the southern hemisphere, it's quite easy to spot Betelgeuse glowing at dusk. Even in the northern hemisphere, it can be seen as the nights grow longer. A researcher from Swinburne University in Australia emphasizes that Betelgeuse offers one of the most fascinating opportunities for scientists, observing the final stages of a massive star's life in more detail than ever before. This allows astronomers to gain significant insights into what happens to red giant stars just before they explode as supernovae. 3 minutes and 18 seconds. There is speculation that Betelgeuse might become so luminous that it could even shine during the day, casting shadows at night. This remarkable behavior has captured the fascination of both professional and amateur astronomers alike. Eventually, Betelgeuse will meet its end in a spectacular supernova explosion. From our location, about 650 light-years away, we will have the rare opportunity to witness this cosmic phenomenon in real time. Heidi Morris, a scientist at Los Alamos National Laboratory and president of a local astronomy club, shares that people have long been captivated by Betelgeuse, closely monitoring its changing brightness. Astronomers have known for a long time that Betelgeuse experiences cycles of intense brightness followed by periods of fading. This cyclical pattern was observed even by ancient Australian Aboriginal and Greek cultures. What is Betelgeuse, and why is it so important? Betelgeuse's brightness cycle spans about 400 days, but recently it has been fluctuating much faster, around every 130 days. Andrea Dupree, who has been studying the star, points out that this accelerated behavior began in 2019 after Betelgeuse forcefully expelled parts of its outer atmosphere. These brightness fluctuations are highly atypical for Betelgeuse, raising the question, does this suggest that the star is on the verge of exploding into a supernova? According to a study co-authored by Dupree and scientists from Harvard and the University of California, Berkeley, it is predicted that it could take 5 to 10 more years for Betelgeuse to return to its normal cycle. The paper states that Betelgeuse has not been the same since the Great Dimming event and has exhibited distinct changes in both its luminosity and radial velocity. Despite the unusual behavior, Betelgeuse still has a long journey before it eventually undergoes its supernova transformation. As a red giant, Betelgeuse goes through a series of fusion processes involving elements such as helium, carbon, oxygen, silicon, and iron. The immense pressure in the core of the star allows helium to fuse into carbon, after which the star continues fusing carbon and helium to form oxygen and other heavier elements. These fusion reactions will eventually cause Betelgeuse to collapse under its immense gravity, which could lead to the formation of either a black hole or a neutron star. Could this be the precursor to a supernova? Current observations of the chemical makeup of Betelgeuse's atmosphere indicate that it is in the early stages of this fusion process, specifically fusing helium into carbon in its core. A rapidly evolving star, Betelgeuse has led an intense, fast-paced life. As it nears the end of its accelerated evolution, it will eventually exhaust its fuel, causing the core to collapse and leading to an explosion so massive it could outshine entire galaxies. While the occurrence of a supernova is inevitable, the exact timing remains a subject of debate. Despite much speculation about when Betelgeuse might explode, there remains uncertainty. Peter Brewer, an astronomy professor at the University of Portsmouth, who specializes in supernovae, has written a book on the topic. He highlights the fact that we currently have no reliable way to predict when stars will explode. Therefore, there is no clear indication of when Betelgeuse will meet its explosive end. This uncertainty is understandable. Throughout human history, there have been very few supernovae observed in sufficient detail. Given this lack of certainty, we still don't know if any of us will live to witness the awe-inspiring explosion of Betelgeuse. The grand scheme of stellar evolution. The life cycle of stars like Betelgeuse offers an exceptional opportunity for astronomers to explore the very final stages of a star's existence. Understanding these stages is crucial, as it brings us closer to comprehending the complex processes that govern the death of massive stars. What scientists are saying about this phenomenon? By virtue of its size and proximity to Earth, Betelgeuse serves as an unprecedented living laboratory for such research. Stars like Betelgeuse begin their life in a relatively calm and steady state, fusing hydrogen into helium in their cores. This process continues for millions of years, but as the fuel runs out, the star undergoes significant changes. For red giants like Betelgeuse, this involves the expansion of the outer layers, causing the star to enter an unstable phase where it begins to pulsate. This expansion is so extreme that it can cause the star to grow to many times its original size. The future of Betelgeuse and what's next for space exploration. The mystery of Betelgeuse's accelerated pulsations in recent years adds a new layer of complexity to our understanding of red giants. As for its eventual collapse into a supernova, Betelgeuse is not yet at that point. There are still many stages it must go through before the final explosion. Will we witness the explosion? Despite the inevitability of Betelgeuse's eventual demise, the exact timing remains unknown. Some scientists speculate that it could happen within the next few decades, while others suggest that it may take centuries before the star reaches the point of no return. Regardless of when it occurs, the supernova explosion of Betelgeuse will be one of the most spectacular cosmic events ever witnessed by humanity. For a brief moment, the star will outshine the entire Milky Way, flooding the night sky with a brightness comparable to a full moon. Some scientists predict that its light could even be visible during the day and may last for weeks or months before gradually fading. But what will happen after Betelgeuse's explosion? The aftermath of a stellar death. When a massive star like Betelgeuse explodes, it releases an enormous amount of energy, scattering elements such as carbon, oxygen, and iron into space. These materials will eventually mix with interstellar gas and dust, contributing to the formation of new stars and planets. In a way, Betelgeuse's death will give birth to new celestial bodies, continuing the cycle of stellar evolution that has shaped our universe for billions of years. But what will remain of Betelgeuse itself? There are two possible outcomes. 1. A neutron star. If the remaining core is between 1.4 and 3 times the mass of the Sun, it will collapse into a neutron star, an incredibly dense object where a teaspoon of material would weigh billions of tons on Earth. 2. A black hole. If the core is more than 3 times the mass of the Sun, it will collapse further, forming a black hole, a region of space where gravity is so intense that not even light can escape. Astronomers are eager to observe this process in real time, as Betelgeuse's fate could provide crucial insights into how black holes and neutron stars form. How will the supernova affect Earth? Given that Betelgeuse is about 650 light-years away, its explosion poses no direct threat to Earth. However, the event will still have a profound impact on our planet. The burst of gamma rays and cosmic radiation will create a stunning light show in the sky, but it won't be strong enough to cause any harm to Earth's atmosphere. Instead, it will offer scientists an unparalleled opportunity to study a nearby supernova, something that has not been observed in such detail for centuries. The last supernova visible to the naked eye was SN 1604, also known as Kepler's supernova, which was observed in 1604. Since then, no supernova in our galaxy has exploded at such close proximity. With modern telescopes and observatories, astronomers will be able to track every stage of Betelgeuse's explosion, helping them refine their understanding of stellar evolution and cosmic explosions. A new chapter in astronomy. For centuries, Betelgeuse has fascinated astronomers, scientists, and stargazers alike. Its mysterious fluctuations, unexpected dimming, and sudden brightness surges have kept researchers on the edge of their seats, wondering whether they are witnessing the final days of a dying star. If Betelgeuse does explode within our lifetime, it will not only be a once-in-a-lifetime spectacle, but it will also mark the beginning of a new era in astrophysics. Telescopes on Earth and in space, such as James Webb Space Telescope, JWST, and the upcoming Vera C. Rubin Observatory, will capture every moment of the explosion, allowing scientists to analyze the birth of a supernova in unprecedented detail. Moreover, the data collected from Betelgeuse's supernova will help researchers predict the life cycles of other massive stars, including those that might explode millions of light-years away.